control.
Okay guys, so dumako naman tayo sa topic na shearing deformation. Okay, so what do we mean by shearing deformation? Gumanaw ng slide. Okay, so what do we mean by shearing deformation? So shearing deformation, shearing force causes shearing deformation. An element subject to shear does not change in length but undergoes change in shape. So ano ba yung ibig sabihin dito? So makikita nyo sa diagram, buksan ko lang yung pointer. Okay, so dito meron kang applied shear force kung saan nakapag-produce siya ng shearing stress. So diba ang ating shearing stress, ang definition niya, the load P is parallel do sa cross-sectional area na ina-analyze natin. So ang tendency niyan is mag-slide against each other. So with that sliding force, kung mapapansin nyo dito sa sunod nating diagram, nagkaroon ka ng change in shape. So in short, yung iyong before rectangular siya, naging parallelogram, or tumabingi yung ating rectangular figure. Okay, so yung shearing strain is denoted by the shearing deformation delta S over the total length or the original length of the element na kino-consider natin. Di ba parang ito yung sa nauna nating topic, yung change in length over sa original length. So ganun lang din yun, shearing deformation over L. So ito yung ating shearing deformation. Ito yung ating original L. Again, ito yung shear strain. So ang shear strain is denoted by the symbol gamma. So wag malilito kasi si gamma, magkikita kayong dalawa ulit niyan sa soil mechanics and also foundation, etc. And also fluid mechanics, mabenta rin to sa mga fluids. Excuse me. So the change in angle at the corner of an original rectangular element is called the shear strain. So ito nga siya, yung ating gamma. So the ratio of the shear stress and the shear strain gamma is called the modulus of elasticity in shear. So meron pala tayong tinatawag pa na isang modulus of elasticity in shear, or modulus of rigidity, and is denoted by the symbol G. So itong G to, makikita kayo niyan later on sa susunod na topic, yung ating theta. So ang theta mo will have a formula of TL all over JG. So sa rotation naman siya, or yung twisting action. So sa akin yung naproblemahin, ito muna tayo. So, pinaliwanag ko lang, So, G again is the ratio. Ano nga ang ratio ng ating G? So, siya is shear stress over the shear strain. So, saan, if you're going to solve for the shear stress, that is G multiplied by gamma. So, shear stress is just the product of the G multiplied by gamma. Again, the shear stress is equals to the shearing force, denoted by the symbol V, over the sheared area, so denoted by AS. Meanwhile, yung ating gamma, so that is equals, o yung gamma natin again is the shear strain, that is just the ratio of the shear deformation over the original length. And if you're going to substitute that from the original equation, our equation will be just like this, okay? Okay, so if you're going to solve for the shearing deformation, that will be just equals to V, or the shearing force multiplied by L all over area sheared multiplied by G. Okay, so next, we will now discuss the Poisson's ratio. So what is a Poisson's ratio? When a bar is subjected to a tensile loading, there is an increase in length of the bar in the direction of the applied load. But there is also a decrease in a lateral dimension perpendicular to the load. The ratio of the sideways deformation or strain to the longitudinal deformation is called the Poisson's ratio, and it is denoted by the symbol V. Meron pa kasi siyang isang symbol. Hindi lang siguro nakita yung ating symbol doon, but itong V to can be written also as, gamitan ko lang ng pen. Yung pinasosyal na V to eh. Or, lagyan na lang natin dito ng or. Ayan. So yan din si Poisson's ratio. So again, this is just the ratio of the sideways deformation to the longitudinal deformation. Okay. So kung i-imagine mo kasi, tama namang kasi ito eh, di ba? Dun sa portion na nagkaaroon ka ng elongation do sa longitudinal direction, there is a corresponding changes also do sa lateral. Nagkaaroon ka kasi ng decrease in size, lumiliit, di ba? So imagine mo na lang, habang binabatak mo siya, lumiliit yung kanyang lateral dimension. Okay, so yan yung pinapakita dito sa diagram. So the original diagram, itong ating naka-solid solid portion. O ito, ayan siya. Ngayon, upon the application of the actual load P, ang titingnan mo ngayon is yung diagram na naka-hidden line o yung broken line. Ano? So kung mapapansin nyo, lumiit yung kanyang lateral dimension. But yung kanyang original length o when it comes to the longitudinal direction, humaba naman siya. Ano? So again, the ratio of that is just the Poisson's ratio. Ayan, so ito siya. So meron tayong dalawang equation for this diagram. Consider this as your x, this as your y-axis, and this as your z-axis. So that is just equals to negative epsilon y over epsilon x, or equals to sa epsilon z over epsilon x. And then sabi dyan, for most steel, it lies in the range of the values of 0.25 to 0.3. And 0.2 for concrete. Next slide. So dito meron din tayo nung biaxial and triaxial deformation. So let's start with biaxial deformation. So ang equation niya, yung biaxial, when it comes dun sa ating strain for x, so that is equals dun sa stress in x over modulus of elasticity is equals to the Poisson's ratio V multiplied by the stress in y over E. And for y, or depende sa axis, so that is equals to the stress in y over E is minus the Poisson's ratio multiplied by stress in x all over E. So kung mapapansin nyo, parang may pattern lang siya, di ba? So doon sa susunod na type, yung triaxial deformation, tip lang, kahit yun na lang yung sa uluhin nyo. Kasi from that equation, madiderive mo naman itong mga equation na to. Itong EX, yung epsilon x and epsilon y. Okay? Next, for triaxial deformation. So if an element is subjected simultaneously by three mutually perpendicular normal stresses, so meron ka ng stress in x, stress in y, and stress in z direction, which are accompanied by strain in epsilon x, epsilon y, and epsilon z respectively. So what will be the working equation? So itong tatlong ito. Guys, again, kahit itong tatlo na lang sa uluhin nyo, kung mapapansin nyo kasi, ang mangyayari lang, if you're going to derive this formula, di ba wala naman siyang z? So mangyayari lang dito, ito sa equation na to, kung mapapansin nyo, ang gagawin mo doon sa z, magiging 0 lang. So, pag sinimplify mo, you will arrive also at this equation. So, sabi ko nga sa inyo, kahit ito na lang yung sa uluhin. And then ako, ang ginagawa ko na lang, tinatandaan ko yung pattern nila. So, mapapansin mo kasi may pattern tong tatlo. Ano? So, dito, for example, do sa strain in X, diba? 1 over E. Multiply, so ang una, yung kapartner niya, which is yung stress with respect dun sa X. So, minus strain, and then quantity, yung dalawang natirang stress. So, gawan nyo na lang ng pattern sa mga isip nyo, no, para mas madali nyo siyang masaulo. And then, kahit ito lang nasa uluin mo, kasi kung mapapansin nyo, yung sumunod na dalawang equation, halos kamukha lang din nito. Ano? So, instead of memorizing this 5 equation, anong nangyari? Isa na lang yung sa uluin mo. And then, gawan mo ng pattern to derive the other equation. Ano? So, tip lang yun. Nasa sa inyo kung paano siya susauluin. So, ako kasi mahina ako magsaulo eh. So, hanggat magagawan ko ng paraan na umunti yung sasauluhin ko, yun yung ginagawa ko. Ano? Okay, so para mas maunawaan nyo siya, mag-try tayo mag-solve ng mga problems. Okay guys, so basahin natin yung isang problem dito sa topic na to. Ano? So we have a rectangular steel block which is 3 inches long in the X direction, 2 inches long in the Y direction, and 4 inches long in the Z direction. The block is subjected to a triaxial loading of 3 uniformly distributed forces as follows. So we have 48 kips tension in the X direction, 60 kips compression in the Y direction, and 54 kips tension in the Z direction. If V is equals to 0.3 and E is equals to 29 times 10 to the 6 psi, determine the single uniformly distributed load in the X direction that would produce the same deformation in the Y direction as the original loading. Okay guys, so ang pinapahanap natin dito is yung single uniformly distributed load in the X direction that would produce the same deformation in the Y direction as the original loading. So before that, so given nga yung mga actual forces mo dun sa mga axes, isolve muna natin yung stress developed sa bawat axis na binigay with respect dun sa mga actual load given. So unahin natin dito. So we have on the Z direction, we have 54 kips which is in tension. So the stress, saan ko ba pwede sulat? Dito na lang ano. So the stress with respect dun sa Z is just equals to 54 and then divided by, so binigay naman sa diagram o binigay rin naman sa problem yung mga dimension niya, no? So ang kailangan natin is yung area nito. So we all know that ito is equals to 2 inches and this one is 3 inches. So that is 2 times 3. So mamaya na natin pindutin ha. Next will be for the stress in the X direction. So kung mapapansin nyo, tensile siya. So that is sigma X equals to 48. So divided by the area. So kailangan natin is yung area nito. Okay, so knowing that this is 2 and ito is equals to 4. So that is divided by 2 times 4. And para do sa ating Y, so that is in compression kasi papalsok ka. So the stress in Y is equals to 60 then divided by this area. So ano ba yung area na yan? So this is 3 as shown in the figure and the height is 4. Okay, so pindutin natin bawat isang stress. for z, that is 54 divided by 2 times 3, so 6. Or this is equivalent to 9 KSI. So next will be 48 divided by 8. So ito is 6 KSI. Talagang inakalki ko, no? And then yung isa, that is 60 divided by 12. Okay lang yun, para sure. Kasi, aminin nyo man o hindi, yung 1 plus 1 nga, kinakabahan pa kayo. Kinakalkyo pa talaga natin yan. Baka kasi mag-iba yung sagot. Tama ba?
Di totoo yan.
Tama. Okay guys, so since na-solve na natin yung mga values ng ating stresses, so ano nga required? To determine the single uniform lead load in X that would produce the same deformation in the Y. Okay, so ang pinapahanap is yung same deformation with respect to sa Y. Again, so ang gagamitin nating formula dito is yung may kinalaman sa Y. So yung strain with respect to Y is equals, so ano nga yung formula natin dito? So 1 over E, and then quantity of stress in Y, and then minus the Poisson ratio V times the quantity of stress in X plus stress in Z. Okay? So 1 over 29 times 10 to the 6. Ayan, okay. So take note of this. This is in PSI. Therefore, yung mga values natin dito, yung 9 KSI, 6, and 5, i-convert natin to PSI. So, i-multiply lang natin ng 3. Okay? So, stress in Y. Okay? So, but take note of this. As you can see here, this is in compression. Therefore, the value of the stress here is negative. So, negative. So, 5 times 1,000. That will be minus 5,000. And then minus the Poisson ratio na 0.3. And then quantity, stress in X. So 6,000 plus 9,000. Okay, so what will be the strain in Y? So pindutin lang natin sa ALQ. So, unahin muna natin yung nasa loob. So, negative 5,000 minus 0.3 times 6,000 plus 9,000. And then, divided by 29 times 10 to the 6. So our answer is so 1, 2, or that is negative 0.327,632 times 10 to 1, 2, 3. So times 10 to the negative 3. Again, this is in unitless. Okay. So ano bang ini-indicate ng iyong negative sign? So sabi dyan, if this is negative, thus the tensile force is required in the X direction to produce the same deformation in the Y direction as the original force. So, in order to find the equivalent single force in the X direction, so uniaxial stress, so kung maaalala, di ba yung formula natin for Poisson ratio, so di ba siya ay equals lang sa negative of strain in Y over the strain in X, o E sub X over E sub Y. Okay, so if you're going to solve for E sub y, so ano mangyayari sa equation natin? So that will be negative of the Poisson's ratio multiplied by E sub x. And kung maaalala, di ba yung strain natin can be written also as stress over E. Di ba yung ratio of proportionality under yung Poisson's, yung, sino nga yung taong yun? Si Hooke's law. Di ba sabi ni Hooke's law, stress is directly proportional to strain. Kung saan, di ba yung ating, yan, dinerive ko ulit. So, di ba equals lang siya dun sa modulus of elasticity by strain. Okay? So, if you're going to solve for the strain, so that is just the ratio of the stress over the modulus of elasticity. Or this can be written also, since may value na tayo nito, so strain in y is equals to Poisson's ratio, and then stress in x over the modulus of elasticity. From where, di ba yung ating stress in x ay mako-compute natin bilang, so ayan, so substitute nyo lang, negative 0.3276 times 10 to the negative 3 multiplied by E. So nasan yung E? 29 times 10 to the 6. And then divided by, siya ba? Sorry. So divided by, dito ko na lang sulat ha para magkasya. So divided by negative 0.3. So from that, masosolve natin yung stress in the x direction. So ang hinahanap nga agad ulit is yung single uniformly distributed load in the x direction. So, pindutin lang natin. So answer times 29 times 10 to the 6 divided by negative 0.3. So ang ating answer is 31,666.6. Ito is in PSI. Okay, so hindi pa tapos dyan ha. Single uniformly load lang ang kailangan. So saan pa ba yung space na siya dito? Okay. So again, we all know that stress is just equals to P over A. So if you are going to solve for the force P, itong stress na to, i-multiply lang natin nung area. Kung saan yung area niya with respect to sa X is yung area nito, which is equivalent to 4 times 2. Okay? So yung answer natin, multiply natin ng 4. So times 4 and then times 2. And then ito is in a pound. So divide na lang natin ng 1,000 to make it in kips. So that is equals to 253.3. 0.3 kips. Okay, so this is our final answer. So ang kwento niya lang guys, itong mga force na to, lagyan natin ng X. Itong mga force na to, yung 54, 48, and yung 60, pwede mo siyang palta ng isang force lang with respect do sa X, which will produce the same strain na na-produce niya. Ano? Okay guys, so let's proceed with the next topic.